Good morning, folks, and welcome back in. Here we go. Those of you that are looking to see or trying to review how you can find x-intercepts or zeros on TI-83, here we go. First thing you need to do is turn on your calculator, hit the Y equals key here, and notice that my top shelf up here has absolutely nothing lit up. If you do have any of these lit up, what you need to do is you have to hit the up arrow so that the cursor is sitting on it, and then click the button so that it is now unhighlighted. So anyway, back to this. So I'm going to enter my function 2x squared minus 5x minus 6. Now, again, most of what we're going to be playing with is going to be in the basic window, so I'm just going to hit zoom standard. And there we go on that. Okay, now, if you notice, looking at this, it's going to cross in two areas, one there and one there. So what that tells me is that I am going to need to actually do this work twice. So give me 1 second. Okay, so now I can actually draw on this stuff, and I'm going to first off begin by just concentrating on this piece in here. So what I do is I hit second, trace, and I'm trying to find the 0. Now again, x-intercept, another name for that is 0. So I'm just going to hit 0, which is 2. I can either highlight it by using the down arrow or just pushing 2. Now it's asking me for the left bound. What that means is it is asking me, where do you want me to start looking? Any value that is on display here that is to the left of where I find this crossing point to be is going to work. It doesn't matter in this case if I look at, it looks like it's somewhere in between 0 and 2. So anything from 2 to 9 would work. I'll just choose at random, -5. Next, it's asking for a right bound. In other words, it's asking between what areas do you want me to look? Well, and I'm going to say it definitely seems to cross before I get to, I don't know, 1. So I hit 1 there. And lastly, it asks for a guess, and all I need to do is hit enter. And here you go. And now it says that my 0 is going to occur at that point, so I'm just going to say that I've got a 0 at -0.886. Okay, so that's one of my zeros. Now let's try and do the exact same thing, except with my point over here. So I'm going to say, let's go second, trace, which is the calculate feature, and once again, I'm going to pull up 2. So I do here, and once again, I need to tell it where to look. So I'm going to say, I don't know, let's say that the left border is going to be 2, because I can say that this is definitely left of 2, and to the right, I don't know, 6. Okay, really doesn't matter as I'm going to the left and to the right of what I'm trying to shoot for. And there you go. So I'm now going to say that x equals 3.386. Once again, in case anybody's freaking out, please notice this in here, okay? That's not because it's made a mistake. It's because what's happened is the calculator has ascribed a certain value to that location. And because if you zoom in on this, you're going to find it actually has pixels. And I realize that this is doing something that, or having a conversation about things that are a little bit dated. This is called pixel error. So what it's actually saying is the y coordinate, instead of being 0, the calculator wants to tell me that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1. Now, again, that's my y coordinate. I truly hope people are not freaking out about this, because guess what? When I round this to the nearest third decimal place, I am really looking at 0. That's about it, folks. So have yourself a lovely one today, and I will look forward to seeing you in class. Take care.